Hi everyone and welcome back to my channel. So we are in the second video of this series of ninth grade mathematics and we are in the chapter number systems, and in this video we will be doing the first exercise of this chapter. So let's get started. Right. So let us start with exercise 1.1. First question. Do you think 0 is a rational number? Okay. So is 0 rational? That is the first question. If yes, then express it in the form of p by q, where p and q are integers and q is not equal to 0. So that itself is the definition of a rational number, right? So if a number is rational, it should be able to be represented in a p by q form. So can we represent 0 in the form of p by q? Yes. 0 by 1, 0 by 2, 0 by 3, all this is 0, right? All of this is 0. Right? So 0 ones are 0, so 0. That means it is divisible, that means it is 0. Right? So therefore this implies that 0 is a rational number because it can be represented in the form of p by q. Right? So we answered both the questions. So it can be represented in the form of p by q. You can write any one of these, 0 by 1, 0 by 2, 0 by 3, any one of these where p and q are the integers. Okay. And yes, 0 is a rational number. So that is the first question. Now moving on, second question. In the second question, what we are going to do is we are going to write any 6 rational numbers between 3 and 4. What does that mean? We need rational numbers that are there between 3 and 4 on the number line. Right? So any number in between this, any rational number in between this. So let us understand a simple trick that we can do here. So first let us convert 3 and 4 into improper fractions. That is what, let's say 3 into 8 divided by 8, which is 1. So 3 into 8 divided by 8 is what? 24 by 8. Right? Which is basically 3. 3 into 8 by 8 is what? 3 into 8 by 8 is 3 into 1, which is 3. Right? So let us just do that, and let us do 4 into 8 by 8, which is what? 32 by 8. Right? So 24 by 8 and 32 by 8. So this is 24 by 8 and this is 32 by 8. So this is one simple trick where we can get number of rational numbers between two given numbers. So what would be the numbers between this? 25 by 8, 26 by 8, 27 by 8, 29 by 8, 30 by 8, 31 by 8. Right? 1 2 3 4 5 6. We have 6 rational numbers that are there between 3 and 4. Right? So this is one way in which we can get any given number of rational numbers between two given numbers. Right? Okay. Now moving on. Another method is you can take average of 3 and 4. Then whatever number you get, you can again take average of that number and 3, or that number and 4, and you can keep continuing this cycle. Right? Average is what? Average is nothing but let's say 3 plus 4 by 2, which is what? 7 by 2, which is which is 7 by 2, right? Which is what? 3.5, which is of course in between 3 and 4. Similarly, now that you got 7 by 2, you can do 3 plus 7 by 2, which is what? 6 plus 7, 8, 9, 10, 11, 12, 13, 13 by 2. Divided by 2. Yeah. So now we have one number 7 by 2. I'm sorry. Now we have one number 7 by 2. Similarly, we can take the average of 7 by 2 and 3, which is what? 8, 9, 10, 11, 12, 13, 13 by 4, right? This is one more number. Similarly, again, you can take average of this and this. So this is a longer process, but you can also follow this, continuously taking averages of any two numbers, right? Now, moving on, what is the next question? The next question is the third question, which is write any 5 rational numbers between 3 by 5 and 4 by 5. You can follow the same method here. So 3 by 5 into you can say 7 by 7, and 4 by 5 into 7 by 7, which is nothing but 21 by 35 and 28 by 35. So what are the numbers in between these two? Rational numbers in between these two. You can say 22 by 35, 23 by 35, 24 by 35, 25 by 35, 26 by 35. That makes it 5, right? So basically you're just multiplying the number by 1 to get an improper fraction, so that it becomes easier for us to get the numbers or rational numbers between those two numbers, right? Okay, now moving on to the fourth question. The fourth question basically has given some statements, and it is asking us whether they are true or false with proper reasoning, right? So what is the first statement? The first statement is every natural number is a whole number. Now let us see. What are natural numbers? Natural numbers are positive integers. 1, 2, 3, 4, and so on. What is a whole number? A whole number starts from 0, non-negative integers. 0, 1, 2, 3, 4, and so on. Right. So from 1 to infinity are natural numbers, and whole numbers are 0 to infinity. So all the natural numbers are there in the set of whole numbers, right? Therefore, this implies that only 0 of whole numbers is not there in natural numbers, but all natural numbers are there in whole numbers. So this implies that the first statement is true, right? Therefore, the given statement is true. Now, second statement. What is the second statement? Every integer is a whole number. Now, what are integers? Integers, this is a direct solution you have, right? Whole numbers are non-negative integers. And integers are, they can be negative also. They are negative numbers, which they are negative and positive numbers, which are not fractions basically. So you have, okay, let me write it this way. So from minus infinity to minus 1, 0, 1 to plus infinity. This implies that all integers, so this implies that all integers are not whole numbers, because the negative numbers that we have here are not there in the set of whole numbers, right? All whole numbers are integers, but all integers are not whole numbers. So this is how we prove this. Therefore, this is a false statement, right? Now, moving on to the third point. Every rational number is a whole number. Is that true? every rational number is whole. Is that true? It is not true, right? Why? Because rational numbers are numbers that can be represented in the p by q form, right? So for example, 2 by 3. And what are whole numbers? Whole numbers are positive integers, which are basically like 0, 1, 2, 3, and so on. Whole numbers are integers. But all rational numbers are not integers. They can be anything, 2 by 3 and or whatever. So therefore all rational numbers, so this is not an integer, right? Therefore all rational numbers, this is one particular example. So all rational, this implies, this one example itself implies that all rational numbers are not whole numbers. Therefore this statement is also false. Now, moving on. So this was the last question of this particular exercise. I hope you understood. If you have any doubts, do comment in the comments section. So you understood this, right? This is how you prove it. You find out. So basically, to prove any statement true or false, to prove any statement false, one example not satisfying the condition is enough to prove it false, right? But for true, you have to do the opposite. Basically, you have to prove that all the cases of the given statement are true, right? So that is how we prove statements. Now, moving on to the next exercise, we have exercise